Ladies and gentlemen, moving on to our next presentation. Let us take you through the biography of our speaker. Nithin K. David graduated in 2006 from the MDis Industrial Design Program at IIT Delhi and holds a BTech in Electronics and AMP Communication Engineering. He started his industrial design career with the Smania Design Private Limited from 2006, designing consumer durables, personal care products and AMP packaging for various Indian and AMP international brands before co-founding RIOT Labz, a company focused on designing and manufacturing connected Internet of Things devices under the brand name Oakter. Nithin is passionate about product development and AMP is obsessed with projects that interact with humans and how they shape the world. His design philosophy is anchored on mass manufacturability of products as much as aesthetics and usability. Let us welcome Mr. Nithin K. David on the stage.
Hello everyone, and my name is Nithin K. David, and I am the one of the co-founders of RIOT Labz Private Limited. It's a company that specializes in manufacturing connected devices. We are what they call an ODM, or an original device manufacturer. So we design and mass produce electronic consumer hardware products. And we are a fledgling company when it comes to the smart metering industry, but we have been deeply entrenched in the IOT connected devices ecosystem for the better part of the last decade. So I'll share a little bit about the company as we get into the presentation today, and I'm mostly going to be focusing about the part, the dirty bits of, making a product, which is basically like what happens in the production line and what happens at the, in the rooms where you conceptualize, products and make decisions about what is to be made. Because I think the audience here is well versed in what happens once the product comes out into the market and goes out into the field. And mostly about the challenges that we face in maintaining the quality and performance of products out in the field, but while we are making decisions about design and manufacturing. So we started off in a different avatar in 2005 as an engineering and analysis firm from the IIT Delhi incubation center. So for almost 10 years, it has been about design and analysis. And in 2015, actually 2014 was when the conceptualization phase started. From 15 onwards, we have been manufacturing connected devices, and with the ambitions of becoming a leader in the plug-and-play smart home product market in India, which never took off. So it's actually also a story of all the failures before we reached here. So we started off with trying to improve the efficiency of the air conditioning systems with a dream of creating a solar air conditioning unit for the country, and then pivoted slowly into devices which can sense temperature and improve efficiency, and moved on to consumer products like smart plugs and smart IR blasters and things like that. And we had some limited success in the beginning as we were the launch partners for Amazon Alexa in India. When Alexa actually came to India, Oakter was one of those brands which actually was the official brand partners for their products that could be voice controlled. And then of course we soon realized that the consumer smart home product market was exactly not as glorious as in India as it has been turning out in the US, because of absolutely different ways in which the consumers there operate and their needs in life as opposed to ours. And then slowly we moved on to scaling up using and having B2B contracts for these things, and eventually somewhere around late 2021 we kind of decided to pursue what we are very good at, which is building things. And we started working with Paytm to develop their sound boxes. And at that time, which were coming in from China, and they were looking for like an Indian manufacturer to design and build it. And from 2021 onwards, we have been supplying all the sound boxes that you see on in the market, and where you scan a QR code and it tells you how much money you have paid. That is a device that we have built. And right now we are based out of Noida. We have about 2 factories, and which runs into about 150,000 square feet. 25 finished assembly lines, and with a capacity of about 750K devices per month. So this is our core team. We are mostly friends and colleagues from a college who have like a background in technology as well as entrepreneurship. So right now, as we stand here in 2024, we have shipped about 20 million devices, out of which includes everything that is like home automation with Alexa, Paytm sound boxes, music players for Carvaan, karaoke sound bars, connected pepper sprays for the US market, slow chargers for EV, and the core theme is that they are all devices which communicate to a system, using some technology or the other. And about 23% of the devices that we have manufactured so far use 2G cellular network as a primary medium of connection, and 60% plus use 4G network, and 15% is like Wi-Fi, Bluetooth, RF connected devices. So I'd like to generally share with you some unique learnings that we have had in manufacturing and deployment of these internet connected devices. Also starting from a point at which we were operating out of first principle and did not have much of guidance to kind of understand what are the standards, and especially operating out at a time when smart home automation devices were still fighting over whether to use Wi-Fi as a standard, as sub-gigahertz, Z-Wave as a standard, Zigbee as a standard, Thread was just coming up. So a lot of our actual the scaling of these products and the manufacturing of these products worked out of first principles, and we were doing what we thought were the right thing to do. So over the years, we have kind of understood that these 6 of these core buckets are the challenges that we have faced in our manufacturing so far. So which being preservation of unique ID. Like for any connected device, the unique ID is pretty much everything to it. It defines the device. It's your face, right? It defines how it operates on a network. It defines how it is serviced on the network, and what kind of lifetime and longevity it has. Decisions that need to be taken about computing on the cloud versus computing on edge, and for some of the portable devices that we do, which mostly are battery consumption, and how do we optimize battery consumption to give a better user experience. Network choices, like I said first, coming from a time when network choices were, not defined for anybody, picking your battles about are you going to do Wi-Fi, are you going to do BLE, BT, sub-gigahertz, whatever. So those choices, and how did we end up making them? What have we learned about rapid troubleshooting on the field, and how it helps you become a better product manufacturer? And FOTA, firmware over-the-air updates, which is basically the holy grail of any connected device that you make. So let's start with unique ID preservation. So ensuring what's inside is also on the outside is, we all take for granted that when you look at a product and see its serial number or the IMEI printed on it, you assume that, okay, this is true. The product inside is holding, an information which is exactly same as what is printed outside. But making sure that this is a zero error process is a huge challenge when you are doing assembling a device in 55 seconds, for example. And that is all the time you have to ensure that, the PCB which holds the IMI has, tested, it has been correctly mapped onto the product serial number, it has been correctly mapped onto say, the QR codes on your, sound boxes. And what does it influence? So, see, as an industrial designer, we do keep hearing this word called time to magic. So, time to magic in lay terms is what you call product configuration. Like the first time installation of a product is time to magic, right? So, time to magic is a term which is used to denote how quickly does a consumer, an end consumer could be anyone, right? Like when I say consumer, I'm not just talking about like a domestic consumer. I'm talking about a guy who's installing your device on the field, the guy who's installing the meter on the field and configuring it to the system. So time to magic is how quickly your product gets installed and plugged into the system and starts work. So for a smart plug, it's like the first time you turn it on from a phone and your lights come on, that is your time to magic. And for, the second thing is lifetime functionality. Like everything, all your connectivity and serviceability of the product with your systems, like for example, the meter talking to your HES, is all based on this one address. And if your process fails at identifying the product when it leaves the line as the product is true, then your serviceability fails. It's a failed product fundamentally. Supportability is also based on it, and of course accountability and improvement of the product while in the field also is dependent on it. So unique ID preservation is one of the core things that we have faced as a challenge, because in the early days I remember when we had like a large order for smart plugs coming in, and we were doing ID preservation as like you'll take one plug, you read the Wi-Fi signature and you put a sticker on it and you pack and send it. But when you have to do hundreds of them at the same time, then we realized that we did not even design the product to be able to read out its internal ID. So then we had to come up with a solution which is like the Indian ingenuity, where we used a Morse code system where the relay switched on and off to read out its IMEI ID using and had to detect it using sensors. So we used a relay as a communication tool in that. So there are a lot of learnings for this. So what we understand is like designing for testing is not something which a lot of people look at, because these things happen in silos. Like product gets designed and then it comes to somebody for like laying out how the testing system is going to work. So the best approach that we have understood is that when you do the ID, when you do the DFM, when you do the design for assembly, that is a point at which you ask these questions. Like, what are you testing? When my PCB is on the back body, what are you testing? What are the ports and pins that you need accessible at that point on the production line so that you can do your testing without having to disassemble it? And how many stages in a production line is this device going to pass through while it is being asked questions like, who are you? You ask the device every time it passes through a station, what is your name? What is your ID? What stage of test have you passed through? And when these decisions actually happen at the industrial design stage, when at the product conceptualization stage, then what happens is that then the assembly of the product becomes a simple process, because then you know that like at phase number 3, when the subassembly has been created to this point, I have access to these 4 things from which I will read my data. So that is one of the philosophies that we have like kept as core to manufacturing of any connected device, that designing for testing is also a core a concept that you need to think about. Then comes zero trust systems that are gated. So for example, preventing packaging of a product has been a great way in which we have actually managed to get our Paytm sound boxes to get out of the factory with 0 errors when it comes to actual QR code mapping, actual IMEI mapping, because at every stage the device is being asked queries. It is not being assumed as the truth. That is why we call it a zero trust system, because you are assuming that it has not passed the previous test. And unless live servers talk to each other, talk to the device, scan codes, and they all together confirm that this is a product that is ready to be shipped, it will not be even allowed into a packaging box, which happens. And so we have a dedicated team for automation design and maintenance only for testing. And that is something which also has been like a tough learning for us, because things fail all the time. And when things fail, you need somebody who is responsible for it exclusively to be able to handle it. So this entire testing system that I have, I just described for you actually happens in a matter of 2 seconds. And of course, it did not start off as 2 seconds. It started off as 20 seconds, right? I mean, like you iterate, and finally you reach a point at which you are like, okay, this is as good as it can get. So a dedicated team for automation and maintenance is something that, is great for, the unique ID preservation. Also, component tracking built into the assembly process also feeds back into accountability and improvement, right? Tomorrow you see a device on the field which probably had a wrong sticker on it. But then if you know how to track it back, then you know, is it a component failure, is it a logistical failure, which line number at what time, who was sitting there. So that is also the beauty of devices that are network connected. Because you can query them at any time, you can talk to them, you can ask them questions. Like the device is actually a living entity as long as it's connected. So these are the 4 things that we have been doing in unique ID preservation. Then there are decisions about computing on the edge versus cloud. This is, when it comes to anything that is IoT, this is a core decision that you have to take at the design stage, because it affects your cost, it affects your latency, and it affects your reliability and longevity of the product. How does it affect cost? That is straightforward and simple, because the more computing you have on the device, the more components you add to the device. Like for example, like an RTC timer on like something that needs to switch on and on or off at a certain given time, whether network is present or not, has already added on the cost of the battery and the RTC chip and the programming of the product. Whereas something that does this on the cloud and it is only connected as a network node is a much cheaper product to make. But then the question is, like, where do you make these decisions? And these decisions, what we have, so this could be interesting because user experience is a word that we keep saying a lot. And we can kind of call it performance, we can call it, how the product feels. But end of the day, user experience is what these decisions are to be made out of. So we had a product for water tank management called Tank Bolt. So we started off as like a simple smart plug which does all the timing and sensing and everything on the cloud. So when it detects that you don't have any water in your tank, it kind of pumps. Simple, straightforward solution. But then the fault in that design is that your Wi-Fi could be offline. Your cloud may not, it may send the instruction to switch on the motor, but it will not know whether it's been done or not. So in that situation, it makes the product's functionality demands that the calculations are done on edge, it works on the edge. So those are the kind of choices that you make when you are designing itself, whether to compute on the cloud or on the edge. So you make your computing design based on what the experience of the user should be, and you design for those choices. We also, battery life is significant to us because, a large number of our products are, battery based. So some examples, so the Paytm Soundbox, the original design brief was 50 hours of battery life. And right now, only with slight hardware tweaking and a lot of software tweaking, it lasts to 350 hours on the same battery. It's a 2200 mAh battery. It started off as a device which works for 50 hours and now runs for 350 hours on the field. And purely, like significantly firmware and hardware improvements can actually keep doing this. Sabre, so this is a US client that we are working for pepper spray, which is Bluetooth connected. So they had a rechargeable device, and the whole thought of the design team was to actually, why would you recharge a personal safety device? It's something that you put in your bag and you forget, right? You are going out, and this is not something which we in India understand because, pepper spray and personal safety devices are like not exactly what we use here much. But in the US, it's like, they carry it all the time. And why would you recharge a device like that? Every 3 days, if you want to take out your device and recharge. So the whole process of design was such that we wanted to eliminate recharging. So a single cell now with optimization of code and hardware has a 7-year battery life. So you buy it and in 7 years if you have not had to use it, so it's a 1 or 2 time activity, right? If you have to constantly use pepper sprays, you might as well move from that neighborhood. So, hardware choices that need to be power efficient, and software architecture should optimize for power consumption. Then comes the network selection situation, which I think here everybody is familiar with, because then you have got your your RFs and your NB-IoT and your 4G and 2G. So, like I said before, Wi-Fi configuration we have discovered, like it's a curse. Like even now, if you don't have a device that does not have a physical screen or a keyboard or a BT connection, it is nearly like impossible for a non-tech person to connect a device to Wi-Fi. So in non-screen devices which don't have like physical keyboards or virtual keyboards or a Bluetooth connected app, for example, it has always been very difficult for Wi-Fi. And so we were very early in our manufacturing journey, we kind of decided that cellular was the right way to go about it, because one, it's universally available, and in a country like India, I think this is where we are better off than a lot of places around the world, because we, with our population density and how big our cities are and how close together they are, we barely have any network dark spots. So cellular is actually like the backbone of cellular is actually like the absolute best network solution for what we have seen in our experience for India. And of course, like you have issues like network not being available, say 2 floors, like 2 basements down. And those are the things, those are not the kind of places where like say an energy meter would be installed. And we have experienced this because we were working on EV chargers, and we had to do a demo in a second basement, and it was a cellular based system and it did not work. So hence the learning. So, but what we have also understood is that good design can actually trump edge cases. Like there are a lot of situations where low signal strength is not necessarily going to kill your connectivity. So designing your antennas, designing your software, and even your enclosures, because it does have a influence in how much connectivity your device can have. But good design can trump most of the edge cases of that. And I'll give you an example of something like in the next section. So choosing the right network for the correct use case is important. So it is not necessary. There is no such thing as like Wi-Fi is better than cellular, or cellular is better than Wi-Fi, or it is always about, see, the network offers you a certain quality and reach, but the decision of what should this product operate on is something that is very purely based on your specific use case. So any global statements about like this network being better than the other network, I mean, unless the network technology itself is significantly superior, is I think less important than actually choosing the right network for the use case. So as a manufacturer, as a product developer, this is kind of your responsibility, because I think it was mentioned in the SLS presentation also, like once the product goes out into the real world, I mean, it is a battlefield. You have simulated everything, you have designed for all conditions that your team can imagine, but you go out into the field and the device is operating in an environment which nobody can predict. Conditions that get created like 1 in a million for perhaps, but still it will only happen on the field. So these unique challenges also throw a spanner in the works, because it's also giving the impression of your product being fallible, right? And it is not necessarily the case, because it may work in 95% of the situations, but the 5% where it breaks or it stutters is where the image of what your product is going to be determined by that. I mean, we all are people who leave reviews on, about Amazon about our product, and we never write anything nice when things are good. We only go in to give you a 2-star or 1-star review. So yeah, so assumptions are just that, assumptions. So one thing we have done is, so I'll give you an example of what happened very recently. So a batch of products were not working in Chandigarh, where a deployment, and we could not figure out what was going on because it was working all over the country. Same hardware version, same software version, nearly identical, like dates of production. And we are like, why is the device not getting on connection? So immediately we had our people go into the field and debug it on location. And so this particular set of devices were sitting at the border of two cellular towers of two states. So basically they were catching Punjab and Haryana's NITS packets and switching between the two, and they were not being able to sync with the network that they're supposed to be on, because they were constantly catching both. And it is such a unique edge case because it's only physically possible in that particular physical location. So, I mean, I'm not saying that, you will solve it on day one, but constantly being out on the field is something that is a responsibility of anybody who is building a connected device, because the conditions are always different. And field knowledge has to rapidly feed your product improvement pipeline. I mean, it is one thing to actually collect knowledge, but it's also important for that knowledge to be immediately feeding into the product improvement pipeline, because otherwise it's just, a document which says that, okay, this happened. And we also kind of apply a dedicated customer care team as, our responsibility, because instead of waiting for your client to get back to you with a list of problems, it is also a good idea to kind of reach out to, people who are actually installing on the field, using on the field, to get information yourself so that, you can catch things before they explode. Like not metaphorically, of course. Of course.